they don't have loads and loads of kind of headline users of the system, but they do have people like NASA using it who are very big and that kind of thing. So there is kind of a community and a drive to keep it going. And also there's quite a few companies that host RethinkDB, kind of offer hosted services and that kind of thing, and they've said that they're planning to keep supporting it and keep running it. And I know especially that the folks at Compose, which is an IBM company, they're keen to see what the next steps are for Rethink and see if they can kind of actively get involved in that kind of thing. So yeah, you might have read that Rethink has shut down, and you might be worried that maybe this is a waste of your time.
When you say it's on open source, I guess so.
Yeah, I think so. I don't think that you can just contribute to it in any way. I don't know what it's written in or anything like that. But yeah, and you can download it for free and all that kind of stuff.
What's documentation like?
But for actually using the database, yeah, pretty good, I would say. Better than most of them. Okay, so RethinkDB. Let's talk about RethinkDB. It's an open source NoSQL database. It's what I would call a very. Does anyone have much experience with NoSQL databases? Anything that's not a SQL-based thing? Yeah. So yeah. So I would say that Rethink is what I would call a very databasey database, where you have a database and you have tables and you can insert data and you can query it in a number of ways and pull data out, update it, delete it, all that kind of thing. The data is stored as JSON, and it's designed to scale. Right out of the box, it's designed to scale, so you get full support for running in a cluster, for sharding and replicating and all that kind of thing. So you get all of that. It's like kind of first class system kind of thing. And you can manage all of that via their admin dashboard. They put a lot of effort into their admin dashboard. It's probably not something that would be high up your list of things to consider if you're picking a new database, but I do think it's worth a mention because they do really try and make it easy to manage your database, to check performance. We'll see it in a little bit, but it's actually a real-time app all of its own, and you can get live stats for your cluster, for individual servers, for individual tables even, and all that kind of thing. It's really worthwhile. But the main thing is that it's designed from the ground up for building real-time apps. They actually kind of market themselves as being an open source database for the real-time web. This is their USP, the thing that they're trying to use to set themselves up apart from the database. And that's kind of the main thrust of this talk, but it's what we're going to be talking about in a bit. And another thing is that it comes with its own query language, which looks a bit weird. It's definitely pronounced RECL, I'm told, so that's what we're going to call it. And it's a little bit different. It's designed to kind of get out of the way. It's designed to embed itself into your language of choice. So if you're building your apps in JavaScript, like I imagine we are, then your RECL queries are actually JavaScript. If you were building your apps in Python, then your RECL queries would be in Python. And it's a bit of, well, personally anyway, I think it's a bit of an odd direction to go at first look. If you're used to querying databases, it doesn't necessarily make a lot of sense. But it is actually quite good once you get used to it, and it gives you a few advantages. Like if you can use native data structures. So if you're doing a query that requires you to use dates, like to compare dates or something like that, then you can use JavaScript's native data. So if you're a JavaScript developer, then that's quite handy. You don't have to learn this. So that's quite good. Day-to-day. It's also quite a modern database, so it has a whole range of features that you would expect from a modern database, and it even has a few other little tricks up its sleeve. So you get things like MapReduce for aggregating data. So I think somebody said they use Mongo. I think I heard it CouchDB in there as well. So you'd be familiar with MapReduce. And there's all kinds of like logic and maths and string manipulation, so you can twist the data to whatever format you need it in and all that kind of thing. Something that I think is quite interesting is that you have this ability to make HTTP requests as well. So if you have a JSON API somewhere, you can make requests directly from the database, pull data back, and insert that in And we were talking about this a little bit earlier, but it's not very common, I don't think, for a JSON-based store to allow you to join between tables. Again, if you're used to Mongo or Couch or something like that, you can't join across tables, which is quite a limitation. If you're used to coming from a SQL background, joins are kind of bread and butter.
Well, their entire argument is you can't scale if you join because it destroys the shard.
Well, I mean, I'm not a database engineer, so I don't know. But Rethink.
They're quite clear on that.
But Rethink lets you do it. You can join across tables. I don't really know how they do it, but you have you can create secondary indexes as well. So it is actually. I didn't really believe it myself. Actually, I thought it would kind of work, but not be very fast or anything like that. But it is fast. It's good. And then you can do like location-based apps as well. So you can do there's geospatial indexes that let you do things like nearest to searches or along this route searches or in this polygon, that kind of thing. So yeah, it is quite fully featured. Obviously, it depends on your use case. There's some things that it's better at than others. But as a general case database, I've been kind of fiddling around with this for the last month or so, and especially I do a lot of work with Node, and if I was looking for a general case database, then I think I would probably go for RethinkDB over something like Postgres or Mongo or something like that, because it just gives you, I think, it's a little bit more flexible. But obviously, it depends on the use case. I wouldn't be scared of throwing anything at it from my current experience. So, before we look at some REPL, I just want to quickly talk a little bit about what happens on a slightly lower level when we're communicating, because it is a little bit different. When you connect to the database, you're creating a permanent connection. So we talked about WebSockets before being a permanent connection between a browser and an application. So now we're going to create a permanent connection between an application and the database. And any query that you do is not going to return you a data set like you might imagine. It's going to return you what's called a cursor. And the simplest way to explain the difference between a cursor and a data set is that it's kind of like the difference between streaming a movie or downloading the whole movie and then watching it. It gives you certain performance gains where you can just kind of page through the data, kind of iterate through the data as you need it. So instead of having to download 50 megs worth of results, or like having to gather 50 megs worth of results from the server, download it, keep it in your application, you just kind of pull it down row by row as you need to. And it supposedly obviously performs. I haven't done any benchmarks or anything like that, but this is the way they do it. So you get so we get our cursor object, and you get methods like next and each, which lets you like I said, iterate through these results. If you want to do something a bit more traditional, maybe you just want to pull everything back at once. We've got the toArray method there, and that just gets you everything as a directory. So that's when we talk about. We're going to move on to some query examples now. So this is just what's going on in the background. So this is REPL. In the blue box, that's our query. In the green box, that's our response. So like I said, REPL is designed to just embed itself into your language of choice. So we're building in JavaScript, so our query is just JavaScript. It just looks like JavaScript, and it is JavaScript. It's important to know that we're not doing kind of the heavy lifting in JavaScript. That's not where the magic happens, if you like. What happens is that behind the scenes, this will get boiled down into something that is understood by RethinkDB. We pass this up using our permanent connection. We pass this up to the server, and that gets executed across the whole cluster in a very kind of performant way. And it means that you can do quite complex queries on quite a lot of data and get your results back in a timely manner.
Does it come with like a mopping library as well or anything? Or would I have to mop it myself? If I was testing. If I'm going to embed this code, if I'm going to embed the query in my code and require R and things like that, does it have like a mopping library?
Not well, I don't know. But it's I don't know. doing the kind of querying in JavaScript because that would be, you actually write the in JavaScript. So looking at this query, we start off with this R object, and that's like a RethinkDB object or namespace or whatever you like to call it. And then you're just chaining methods of it. It's just JavaScript. So we have the first method, which is DB, which is obviously selecting our database. So we're selecting the JavaScript Northwest database. And then the next method is table. So we're selecting a table, the questions table. And this is just going to get me everything from the questions table. Nice and easy. The SQL equivalent would be something like select star from JavaScript Northwest dot questions. Very, very basic. Then you can see in response, I've just said get me everything back as an array. So we have an array. Each element in the array is an object. Each object represents a row from the table. Very, very straightforward. And to expand these queries, you just keep chaining methods of it. So I don't want to talk about this kind of stuff too much. That's not really what we're here to talk about. But all we've done here is expand this query a little bit to say, get me everything from the questions table, but only where the score is greater than 5. So I think you can see how you would go about expanding this query, make it a bit more complex, be a bit more focused. But like I said, I don't really want to go too much into that kind of thing. But I do want to talk about is a little bit of magic they call change feeds. So we've gone back to our very basic query, and I've added this changes method into the end. And what this changes method is saying is, when any data changes that affects this particular query, then I want you to tell us about it. Or in other words, when any data is inserted into the questions table, or updated or deleted from the questions table, then I want you to tell us about it. And this is just a query like any other query. You write it in the same way, you run it in the same way, it returns a cursor in the same way. And all that happens is, whenever any data changes in a way that we care about, a new event gets pushed to this cursor for me to work with. An event looks like this in the green box. You can see we've got a new value, we get an old value. The new value represents what is currently stored in the database for this particular row. The old value represents what used to be stored in the database for this particular row. So you can see in this example, the old value is null, so it wasn't there before, it didn't exist before. So we know that this is an insert, because now we didn't have some data, now we do. If you were to flip it around so that the new value is null, then you would know that, well, we used to have some data, and now we don't, therefore it's complete. If both new and old had a value, then you know we've gone from this to this, and it was updated. So you know exactly what's going on. You know that it's inserted or deleted or updated or whatever, and you have all of the relevant data to be able to react to it, which is good. And in doing this kind of thing is no more costly in terms of resources than doing any other query. It's not something that you should be scared of doing. You're actively encouraged to do this kind of thing. And you can add changes to almost any query. It struggles with things like if you're doing aggregations like averages and that kind of thing. It can't deal with that just at the moment. At this point, I would usually say that's one of the things they're working on, but at the moment they're not, obviously, because they've got no money. But yeah, if we were to go back to this slide, you could add changes to the end of this query, and that would say, if any data changes in the questions table, I want to know about it, but only if the score is greater than 5. So you can be really targeted about the kind of notifications and the updates that you want to receive, which is quite powerful.
So I give changes a call back to handle the results?
No, so changes is just a query, just like any other query. We'll see in a little bit how you run a query, and then you do kind of you get the cursor as part of the call.
If when we've got the selection criteria, presumably if somebody updates it to a score of 4, does that return the null? Because it's now fallen out of that criteria?
If
you've got score is greater than 5.
Yes.
So if I update it and now give it a score of 4, where it had 10 before, it would effectively not appear in that query, so I'd return a null, presumably.
Yeah, so this would return an empty array. Yeah. If you had the changes thing on the end to get the kind of real-time updates, then if you updated that record to go from a 5 to a 4, then
6 to a 4, because 5 is below as well. It's great.
Oh yeah, sorry. 6 to a then
It is returning.
it would return saying that you did have this record that used to have the 6, but now it kind of doesn't exist in the context of this query. Yeah, exactly. So yeah, that's change feeds, and that's, you know, this is something that you don't get in most databases really, and it's quite powerful. And the upshot of all of this is, if you remember the story I was telling you before, the upshot of all of this is that we're back to having one source of data. So this is what we would have liked to have done back in the day when we were working on that particular system. So we're back to the holy grail of having one source of data, and all that's happening here is that each instance of our application, each server, is simply making one of these change feed requests to RethinkDB, and then these updates get pushed to these servers as they happen. And these servers don't know anything about each other. We're back to that kind of situation where you've got a stateless application. There's no middleman coordinating state anymore. It's just our single database. So if you need more servers, you just add more servers, and they make a query, they make a connection, they make a query, and they receive notifications just like anything else. So that means that scaling now is really nice and easy, because you can just throw hardware at it, which is exactly where we were before you went to the stuff. So now it's time for a demo, and I'm going to try and elegantly switch over to the demo, which is here. So this is the Rethink admin that I was talking about. So we're looking at the left-hand side of the menu. So like I said, this is like a real-time app in and of itself. There's not much going. This is just running locally, so there's not really anything going on. But you get real-time cluster performance, real-time logging at the bottom. You can see the servers in the cluster, which this is my laptop. You can see all the databases and tables. We don't have anything at the moment, so I'm going to create one here. So I'm going to create a JavaScript Northwest database. You can see that just appears. And I'm going to add a table called questions. You see this takes a moment, but I'm not refreshing the screen or anything, and just in a moment that will appear. There it is. And you get real-time usage statistics and all that kind of thing on a table by table basis.
Have an API or anything like that to pull that data out?
So this is just using kind of Rethink's own kind of internal table system. So yeah, you can just query it like any other query. I don't know what those tables are called actually, so I could have maybe shown you that. Yeah. Down here you can reconfigure. So because I'm running on my laptop, I can't actually reconfigure very much, but you can just change the number of shards and replicas per shard, and click the button, and that will just reconfigure all for you, which is much nicer than like Mongo or HowStudio and all that kind of thing. But what I really want to show you though is the Data Explorer. This is the thing that you would probably be using most, and it's quite powerful. So this is just, I always think of historically I'm from a PHP MySQL background, so I always think of PHP in my head and writing my queries in PHP in my head. This is a bit more powerful than that, because you get kind of suggestions here, so it kind of tells you what your options are, like an autocomplete kind of thing, which is quite good, I think. So I want to select my JavaScript Northwest database, and then I'm going to select my JavaScript, my questions table, sorry. So this is just like the example we've seen on the slide. If I run that query, I get no results, as you might expect. We just create it. So that was just a simple what is in this table kind of query. Over on the right hand side, I'm going to do the same query,